Morning. Here's our second discussion over triangles, even though in the first one there was a few things about polygons in general. Let's start today on the number 1. Find the missing angles of the isosceles triangle below. Now, isosceles means that it's got two sides the same length, and you know that that's indicated because you've got these two single hash marks that indicate that those are the same length. Now you need to remember that the angle across, if the sides have the same length, the angle across from the sides have the same length. So that means angle 1 and angle 2 are the same measure. So we could just label both of those x, and then knowing that the angles of a triangle had to be 180, we would have x plus 80 is equal to 180, or 2x plus 80 is equal to 180. And then subtracting 80, then 2x is equal to 140. And 2x is equal to 100, and so x is equal to 50. So each of the angles that we're missing are 50 degrees. Okay, again, remember, if the sides are the same, the angles across from the sides are the same. All right, without being told this is an isosceles triangle, which we are, but we could tell it was, again, because of the hash marks. And they want the measure of YZU is 140. So we're given this angle out here. Find the measure of XYZ. So we're looking for that angle. Okay. So what we know is that this is a linear pair. Okay, YZU. So angle YZU plus angle YZX are equal to 180. Okay, so that means 140 plus, we'll call this one Y. Y equals 180. So Y is equal to 40. So that means Y here is equal to 40 degrees. Now, since this is isosceles, we know this angle and this angle are the same. So that's also 40. So for the triangle then, we have 40 plus 40 plus x is equal to 180, or 80 plus x equals 180. And so x here is equal to 100 degrees. All right. Now, we know for our special right triangles, and y'all have hopefully remembered these, and we used to use x instead of a, but if you have an isosceles triangle with the angles, then they're right triangles, so that means this angle is 90. These have to be the same, so they have to be 45 and 45. That our side to hypotenuse relationship is a, and a times the square root of 2. If you have a 30, 60, 90 triangle, then across from the 60 is a little bit longer than the side across from the 30, because the angle measure indicates a little bit about the side length. So the shortest side is the measure across from the angle, the length or the side across from the 30. A little bit bigger than that is the side across from the 60. And then the side across from the 90, the hypotenuse, is always the largest or the longest side. So that relationship is A across from the 30-degree angle. 2A is the hypotenuse, and the 60 across from the 60 is A times the square root of 3. So knowing that, we're going to go back, and we did a lot of these in geometry. If we know that X here, it says find X, and we know the hypotenuse is 12, well, we know this is 30 because this is 60, so that's 90, that has to be 30. That means 12 is equal to 2A, or 2x. Okay, so x is equal to 6. Okay, the triangle's positionally a little different here, but we know this is 45. We know the hypotenuse, which is across from the 90-degree angle, is the longest side. So we have 3 is equal to x. Okay, and so this one, or 3 is equal to a, maybe that's a better way to put it. And this side is a times the square root of 2, because it's the hypotenuse. If a is 3, then x here is equal to 3 times the square root of 2. Let me erase that. 3 times the square root of 2. All right, here again we have a 30, 60, 90 triangle. This is the side across from the 60-degree angle. This is across from the 30. We're looking for our hypotenuse. Well, if this side is equal to a times the square root of 3, a must be 7. Okay, and the hypotenuse is equal to 2a. So my hypotenuse, x, is 2 times 7, or 14. Okay. So we're going to move on to the next page. Some word problems with, or application problems with using triangles. Pull this up. And okay. What is the height of the tree to the nearest foot? Well, we're lucky. We've got a 45, 45, 90 triangle here. We're given the hypotenuse. Okay. So this here, 50, is equal to x times the square root of 2. And this is x, and this is x. So height and distance from the tree are the same. So x times the square root of 2 is equal to 51. So we're going to divide by the square root of 2 to solve it. Okay. And since we want the height, we're going to, in a tax test, they're probably not going to leave it as a radical. If they did, you remember you don't leave a radical in the denominator, so you would write it like this. But in this case, I want you to go ahead and put it in your calculator and get a decimal answer, and it's going to be 36.062, and they want it to the nearest foot, so it's 36 feet. And this could be a problem that would be bubbled in, something like that, maybe on tax. Okay, Charles is looking out a window from a point 50 feet above the ground, so he's right here. So this is 50 feet. Okay. When Charles looks down at an angle of depression of 30 degrees, that means if he looked straight across, he'd be here, but he looks down, it's 30 degrees. He sees his dog Max. To the nearest foot, how far is Max from the building? Okay, well, want to know this distance. How far is Max from the building? Now, this is, if you remember, this is two parallel lines. If this is 90, that means this whole angle here is 90. So this piece of the angle right here is 60 degrees. That means that this is 30 degrees. We could also know that because if you think of parallel lines cut by a transversal, and I'm not going to make a perpendicular transversal, okay? If you think of parallel lines cut by a transversal, these would be alternate interior angles, and if you look, alternate interior angles are congruent. So that would be an alternate, or this would be an alternate interior angle. So what we've got are alternate interior angles, parallel lines. These are parallel, cut by a transversal. So 30 and 30 are, we could know that without knowing that this was 60, I guess is what I'm trying to say. All right, so we've got a 30, 60, 90 triangle. We know the side across from the 30, and we know that's 50. So in our terms of our labeling, this is A times the square root of 3, and this is 2A. So if we know that 50 is A, then X is 50 times the square root of 3. Since we want it to the nearest foot, we're going to have to go ahead and put it in the calculator and find that X is equal to 86.603, and to the nearest foot, that's going to be about 87 feet. Okay. Here we have a cable for power transformer, forms a 60-degree angle to the ground as shown in the figure. What's the length of the cable to the nearest foot? Okay. So here's a pole, here's the cable, and so we're looking here now for the hypotenuse. So this is across from the 60, that's your A times the square root of 3. This is A, and this is 2A. So we've got to figure out what A is. So 28 is equal to A times the square root of 3, or X times the square root of 3, however you want to do it. All right, divide by the square root of 3, so A is equal to 28 over the square root of 3. But what we're looking for is the length of the cable. The length of the cable is equal to 2A, so that's 2 times 28 over the square root of 3. Okay, and when you put that in your calculator, because you want it to the nearest foot, you find that the length is about 32.332, or rounded, length is equal to 32 feet. Okay. All right, get busy on your work. This will be due I'll answer questions about it on Tuesday, but it will be due Thursday. So you have but I want you to, this is tax review, so I want you to be sure to get this done.